Good morning, game theorists, or afternoon, or evening, or night, depending upon when you are watching this. So, to finish up chapter 16, we will look at some examples of all pay auctions, so you can start applying those results we showed earlier to some sample problems. In our first example, we'll have 4 bidders, and they're all going to have the same value they place on the object. Let's say all of them think the object is worth 70. So one thing I could ask you is, what's the probability of one bidder bidding something below 40? So first we can set up our problem. We know that the expected payoff is going to be, well, you break it down to its components. If you win, you get V minus B. The probability that you win is going to be probability that your bid is bigger than everyone else's. There are 4 bidders here, so you have to outbid 3 other people. So P of B cubed is the probability that everyone else's bid, all 3 other people's bid, is below your bid. So our big P here is the cumulative distribution function. So the probability that their bids are below B. B is your bid. So that's what you get if you win, and that's the probability that you win. If you lose, you get minus B. The probability of losing is going to be 1 minus P of B cubed. So if the probability of winning were, say, I don't know, 30%, then the probability of you losing is going to be 70%. More generally, this is the probability of winning, then 1 minus that is probability of losing. And we can simplify, so we have V is P of B cubed minus B times P of B cubed. So I'm just expanding this term. I'll do the same over here. Minus B plus B times P of B cubed. These guys are going to cancel. And we know what V is. We said V is 70. I could plug that in. So we have 70 P of B cubed minus B. That's expected payoff. So we had that trick that I mentioned that the foundations of it were dubious, but the trick does work out. The trick your book mentions is you set that equal to 0 to solve. And I'm trying to solve here for P of B. So try to solve for the distribution of our bids. So I'll push that B to the other side. B equals 70 times P of B cubed. Next step, divide both sides by 70. Last step, let's raise everyone to the power of 1/3. So that is the probability of bidding less than B. So my question here at the beginning was about bids below 40. So what's the probability that you bid below 40? Just plug 40 in for B. And that's going to come out to 40 over 70 raised to the 1/3. You can do some cancellation of the zeros. So we get 4 over 7 raised to the 1/3. And that's your answer. So it's probably 4/7 raised to the power 1/3. You're going to bid less than 40. All right, let's try another example. Let's do one with an all-pay auction where the people have different values. So we said that if you have 3 or more bidders and they all pay with different values, then only the top 2 end up bidding. So let's go back to the 2-bidder case. Who are some of our typical volunteers? Khalil volunteers sometimes for these games, so hope you're okay with that. I'll put you in this example, Khalil. Let's say he thinks the item is worth 100. Another one of our volunteers is Joanne. Let's say Joanne's value is 80. So, some questions we could explore. How likely is it that Khalil bids below 50? You could also ask the same thing about Joanne. How likely is it that she bids below 50? All right, how do we tackle this one? So in our previous episode, we had V1 and V2, and we assumed that V1 is always bigger than V2. I said that assumption was harmless. That's because you can always define V1 and V2 in such a way that it's true. So Khalil's got the bigger value here. So I'll define that to be V1. So I'll call Khalil bidder 1, and Joanne is bidder 2. So if I assign it that way, then the assumption V1 greater than V2 holds true. And now we can go back to the results we had earlier. So earlier I demonstrated, well, I claimed that the following was true. So for bidder 1, P prime of B, that is their PDF, their probability density function, was equal to 1 over V2. In this case, that means 1 over 80 because we said V2 is 80 in this example. So if we draw our graph, so notice here, this is P1 prime of B, not P1 of B. Therefore, unlike the last problem, I can't just plug in B equals 50 and be done. It's P prime, not P. So the way the P primes work, the PDFs work, is the probability is the area under the graph. So here P1 prime of B is 1 over 80. So if it has a height of 1 over 80, then the base had better be 80. That ensures that total probability is 1. So the probability of Khalil bidding less than 50, first 50 on our graph, and then with the PDF here, it's the area under the graph between 0 and 50. So all the area below 50. So it's that shape. So what's the area of that rectangle? Rectangle area is always base times height. Base is 50. Height is 1 over 80. So that comes out to 50 over 80, which is 5/8. So that's how likely it is that Khalil bids below 50. So that answers the first part of our question. I also asked, what's the probability of Joanne bidding less than 50? So we showed earlier that, what did we show? We showed that there's some probability that Joanne always bids 0, and there's some other probability that she bids something that's positive. So bid 0th probability 1 minus V2 over V1. That's what we showed in a previous episode. And then with probability V2 over V1, then Joanne's going to bid according to that same rule, that we had earlier. So now we can plug in our numbers and see what that means. So we're going to focus on this case here because, well, let's first figure out what this probability is. So V2 over V1 is going to be 80 over 100. That simplifies to 4/5. So this becomes, with probably 4/5, we bid according to that rule. And that rule becomes 1 over 80. So the other times, which will happen 1/5 of the time, bid 0. So as you can see, Joanne's problem is a little bit more complicated. All right, so let's draw the PDF for Joanne. So draw her P prime. So as before, the height's 1 over 80. Our base has to be 80. So here's 50. Because you're looking at P prime, not P, looking at a PDF, not a CDF, the probability is going to be the area under that rectangle below 50. So that'll be this box. Again, that'll happen to probability 4/5. So as usual, base times height, area is going to be 50 times 1 over 80, which comes out to 5/8. Now, that happens with probability 4/5. So 4/5 of the time, we bid according to this rule, and that rule 5/8 of the time gives you a bid less than 50. So that boils down to, we get some very nice cancellation here of the 5s. 4 over 8, which gives us some even more nice cancellation, 1 over 2. Now, the other 1/5 of the time, she bid 0. Well, a bid of 0 is less than 50, right? So that still counts. So you got to add that probability of bidding 0 to this to find the total probability that Joanne bids less than 50. So you have 1 over 2 plus 1 over 5. Let's get a common denominator. So 1/2 can be written as 5 over 10. 1 over 5 can be written as 2 over 10. That comes out to 7 over 10. So that's how likely it is that Joanne bids below 50. So as you can see, it's a little more complicated for the second bidder because there's some probability to bid 0 and some probability of a positive bid. You gotta think about both of those. So that wraps up Chapter 16. Be sure to tune in for our next episode in which we look at Chapter 17 on bargaining.